Hello and welcome back to yet another video, and in this video I would be doing something different. I won't be taking a question, rather I would be attempting a random unseen mock test, rather a mock interview in front of you, so that we get to know that how we should think in an interview and how we should handle or tackle unseen questions. So I'll just go here, and this is a mock interview pattern, and I'll just go and start my mock interview. And the questions are insanely random, and there's very less probability that I have seen this question earlier. So I think this would be a good test of my good evaluation of my skills. So let's jump into it. Okay. Okay, here's one question and here's another question. Alright, great. So let me start with the second question. In row of seats, 1 represents a person sitting in the seat and 0 represents that the seat is empty. Okay, there is at least one empty seat. Okay, one thing to be let me make it clear, I haven't seen both of these questions earlier, and that's an honest answer. That's an honest review. Okay, so Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized. Alright, return that maximum distance to the closest person. Okay, if Alex is in the second open seat, so alright, so what I think is, okay, let me do some one, so I have this. Okay, alright, so 1 represents the person that is sitting in the seat. Okay, so I want to place Alex in such a seat that the distance between him and the closest person to him is maximized. Great. So Alex is an introvert and he wants to sit in the maximum distance possible. Great. Okay, alright, alrighty. Okay, okay. So if I sit here, then the closest person to him is 1 unit away. If I sit here, then the closest person to him is 2 units away. If I sit here, then the closest person to him is 1 unit away again. Okay, then if I sit, I cannot sit here, and if I sit here again, the closest person is 1 unit away. Alright, okay, so that seems kind of fair. So let me think, what can I apply in such a situation? What kind of algorithm can I think of? Okay, in that situation, Alex is in the last row, right? Okay, alright, I need to find a 0 which is maximum from the closest one. That's what I need to find. Okay, so okay, alright, so what I'll do is, maybe I'll have an array. I'll call this distances, and maybe I'll see what is my closest to 1 at every index. So this is 0 because it's always a 1. For this index, I'll see my left hand side and my right hand side. So my left hand side is a 1, so I'll have the maximum of both maybe, or alright, so I'll have the minimum of both, so I will have 1. Okay, then for this index I have a 0 on this side, I have 0 on this side. So this 0 has is 1 unit away from a 1, so I'll check my right hand side also, but I'll see that it's not a 1. So this 0 is 1 plus 1, that's 2 units away from the nearest one. And this 0 is, if I check on the left side, on the left hand side, then this 0 is maybe on the left hand side I have a 0, so basically that would basically be 3 units away from a 1. And but on the right hand side I have a 1, so that's basically 1 unit away, so the minimum is 1, right? For this particular one, since it's 0, so I'll have 0. For this particular 0, I'll see my left hand side, and that's a 0, so I'll have 0 plus 1, that's 1. And for this again I'll have 0, so the maximum distance happens to be at index 2, and hence I'll return the answer. So does it work for every case? Maybe let's say I have this. So for this I am having for this I'll just check on the next character, or I should have a left traversal and a right traversal, right? For every 0 I need to check the nearest 1, for every 1 I need to check the nearest 0, I mean 2. For every 0 I need to check the nearest 1 on the left side and the nearest 1 on the right side. So maybe I'll have to have 2 traversals. Okay, I'll have 1 traversal from here and 1 traversal from here. So if this is 0, so this is 0, this becomes 0, so this is 1, this is 2, this is 3. Yeah, so maybe I will have 2 traversal. So let's see if the idea works or not. So I'll have vector int of distances, I'm having my seats, so that's great. So what I'll do is maybe I'll have seats dot size. Okay, so it's told that there is at least 1 empty seat, so I can sit there. So since there is at least 1 empty seat, so I will have a value, I will rather have a vector that has at least 1 number of 1s. So n would be seats dot size. That's okay. So I don't need to check for n since there will be at least 1. So I'll do distance of maybe n elements. Alright, and I'll set everyone to 0. Now for int I equals 0, I less than n and I plus plus, maybe if I start with 0, so I don't have a 1 there, so I'll have a 1 here, or it doesn't make sense. So okay, yeah. So if I start with 0, right, if I start with 0, let's say I start with 0, so I don't have a 1 on my left hand side, so the distance here would be infinity. Okay, because when I will be traversing on the right again, then this distance would be set to whatever the distance the actual is, but still then it would be set to infinity. So maybe let's set it infinity. Alright, so how can I do that? So I'll start with my left. So if my okay, so my int current becomes infinity. Okay, so that becomes max of int. I think that's cool. So if okay, so let's do one thing. If distance of 0, that's the first element, if it's equal to 0, okay, if it's 0, then I have infinite distance from my left hand side one, because there is no left hand side. So I'll basically mark dist of 0 is equals to int of max. Okay, let's remove all this. So I'll have distance 0 equals to int of max, else I'll have dist of 0 is equal to 0. So basically I'll start my loop from 1. So if dist of I minus 1 equal to infinity, then this I would also be infinity. Okay, else this dist of I would basically be nothing but dist of I minus 1 plus 1, right? So that's one loop. In the second loop I'll start from the last element. So maybe let's say in the last element I have 1, so it would be 0. And one thing that I need to, okay, so yeah, if my seats of I is, if it's equal to 1, then I'll put my dist of I as 0, right? Correct. Else if this, else this, maybe that would do. On the second run I would have if there is a 1, so that would basically be yeah. So on the second run also I'll start from int I equals to n minus 1, that's from the right hand side. So yeah, I would be I'd rather start from n minus 2 maybe. Yeah, I greater than equal to I would be greater than equal to 0, I minus minus. Okay, so what I'll do maybe is dist of list of n minus 1. I'll see whether okay, so this is basically not dist, this would be seats. I'm checking the array. So basically here also, if seats of n minus 1, if it's equal to 0, so on my right hand side I don't have any value. Right, on my right hand side I don't have any value, so that would basically result into infinite. So what I'll do is I'll not update, so I'll have dist of n minus 1. I would have, with 0, then I would have it as equal to or do I need to let me see if I need to, or do I not. So if it's 0, so maybe I'll set okay, so okay, let's do one thing, right? So its name is dist, so let's name this left. Okay, so what I'm trying here is to simplify the code a little. I am counting my left and also I'll be counting my right, so that's left and this is left. Okay, so I'll set everything to int max. Okay, I think I need a little tweak over here. Let's set everything to int max. Okay, so let's start from 0. So int I equals 0, I less than n I plus plus. If my seats of I is equal to 1, then I will set my left of I to be 0. Else if my else if that seats of I is equal to 1, so I will set my left of I minus 1. So if seats is 1, then that's 0, I don't have anything, so I'll just continue. Okay, maybe this is infinity, everything is infinity first, so this is 0, correct? So if it's 0, then I don't have anything, I'll just go and continue. Okay, so let's do one thing, let's make an extra. Yeah, now this would be perfect, I believe. I1 I less than n, yeah, so less than or equal to 1. I think now it would be perfect. So if I minus 1 is equal to 1, then left of I would be 0. If left of I minus 1 is equal to int max, which is it is in the first place, the left of I would be int max, else left of I would be nothing but distance of, so this would be basically left of I minus 1 plus 1. Yeah, I think this is perfect. Similarly, I'll have a vector right array, I'll have n plus 1, I'll have int max here also. Okay, I'll start from n, correct? I'll start from n, so that's the last. So I'll keep on populating my n, so that would be if my seats of I minus 1, right, so that would be greater than 0. So my seats of I minus 1 is equal to 1, then I would tell that my right array of I, right array of I is equal to 0, else if my right of I plus 1, that's so let me see, I'll start from my left element, so maybe I would n minus 1th element. Okay, I'll start with n minus 1th element. If seat of I, okay, so let me walk over here. What I'll start, I'll make everything, if this is 0, I'll have an infinite added over here. Okay, so I'll start with my n minus 1th element, I'll go up till 0. I think that's right. I'll go up till 0, and what I'll do is maybe let me think. I start with 0, and if I have my last but one element to be 0, if I have my last but one element to be 0, okay, so maybe start with my second last element, correct? Yep. If seats of I, yeah, this is what I'll do. If seats of I is equal to 1, I'll do a right of I, that is my n minus 1th element. Since n is my size, so n would be the last element, so n minus 1th element would be 0, right? Else if right of I plus 1, yeah, if right of I plus 1 is equal to int of max, okay, so if this int of max, I'll have my right of I to be equal to int of max, else I'll have my right of I to be equal to my right of I plus 1, just my right element, plus 1. Maybe, yeah, maybe that's correct. So let's create a final distance vector. Now for int I equals to 0, I less than equal to n I plus plus, I will just have this dot pushback. I'll keep on pushbacking the elements from the first, so I'll discard the first element, I'll start from the second. So that's I plus 1. So basically left of I'll have the minimum distance. This is the minimum distance, correct? The minimum distance between the left of I plus 1, correct? And let's go till n. So left of I plus 1 and right of I, right? Right of I, yeah. Maybe that would do. So max of these two elements. And distance pushback, max of these two elements. I'll have my answer to be 0. Now for int I equals 0, I less than n, right? I less than n, yeah, I plus plus. So if so, let's have a min distance. Okay, min distance equals to int min. So if my distance of I is greater than so this is greater than int min, or rather min distance, the minimum distance. From all these minimum distance I have to find the maximum. So these are the minimum distances, I need to find the maximum. So if my minimum distance of I is greater than min distance, so my min distance becomes distance of I, and my answer becomes I, maybe. Return the maximum. Okay, alright, I don't need to find the position, I need to return the maximum distance. Okay, that's actually pretty easy. So if that's the thing, so maybe I'll just return the max element of distance. Let's see if the code works. Yeah, for this it works. I think, let's see if the code works for this example. Yeah, it works for this also. Let's submit the code. And bingo, it's worked, right? So yeah, this is the concept, right? So this was a complete random code that I've just done. So let's see if I can complete this also. X is a good number if after rotating each digit individually by 180 degrees we get a valid number that is different from x. Each digit must be rotated. You cannot choose to leave it alone. A number is valid if each digit remains a digit after rotation. So 0, 1 and 8 rotate themselves to 2, 5. What? 0, 1 and 8 rotate to themselves. Okay, great. 0, 1 and 8 rotate to themselves. 2 and 5 rotate to each other. Yeah. Right. 6 and 9 are rotated to each other, and the rest of the numbers do not rotate to any other number and become invalid. Okay. So now given number, how many numbers x from 1 to n are good? So a number should contain 0, 1, 8, 2 and 5, if I am not wrong. Okay, so 1, 2, yeah, right. So the number should ideally contain 0, 1, 8, 2, 5 and 6, 9, right? So if a given number is 10, so there are 4 numbers that contain all these numbers, so maybe 2, 5, 6, 9 is the correct answer, and 8, these are not there. Yeah, I think it should be pretty easy. The number should contain 5, 6, so okay. So what I can think of is a complexity of n into d, where n is the range of numbers from 1 to n, and d is the length of the digit, length of the number, right? So yeah, that's not too huge, because n would be, d would be small always. Since it's an int, the maximum d can be 10. That's it, right? The maximum d can be 10. So I think I can consider that checking of d to be a number, maybe a constant, maybe. So let's check for d. Maybe let's do one thing. I'll pass on a number int a, and I need to check for the digits. So maybe since it's an integer, the maximum digits it would contain is 10, right? So maybe while a greater than 0, that's what I need to do. So my int digit, whatever it is, it becomes, let's start from the last, a mod 10, right? A b, so let's do one thing. Let's have this d equals 0 initialized. So d becomes a mod 10, a becomes a by 10. Meanwhile I need to check for d. So if d is equal to any one of the following, so basically 0, 1, 2. So if d is equal to, okay, 2 is also there, so 3 is invalid. So if d is equal to 3, or d is equal to 3, or 4, maybe, yeah, 4 is invalid. 5 is there, 6 is there, 7 is there, no. So if d is equal to 7, is 8 there? Yes. 9 there? Yeah. So all other numbers are invalid. Let me quickly check. There are 3 numbers, and 1, 2, 3, 4, 5, 6, 7. Yeah, so there are 10 numbers. If d is among any of this, I'll straight away go and return false. Else I'll keep on doing it, and if I completely stop doing it, that means I have passed the whole number. I've seen all the digits. I'll just return true. So I'll have a count. I'll have a counter maybe. So for int I equals 1, I less than equals n, I plus plus, I'll just check. So if check I, right, if check I returns true, then do a count plus plus. Maybe that's it. At the last I'll return count. I think this should be good. No, it's giving me 7. Okay, it should ideally give me 4. Okay, let me see what the error is. When a is greater than 0, d would be a mod 10, that is a digit. D would be a mod 10, a would become a by 10, and if d is equal to 3, or d is equal to 4, or d is equal to 7, I'll return false. Right, so let's say for 1 I return true, right? For 1 I return true. For 2 I'll return. Okay, alright. So 1 and 10 are not good numbers since they remain unchanged after rotating. Alright, I'm extremely sorry. They remain unchanged. Okay. Alrighty, I get the question. So if it's 1 and 8, so numbers like 88, they remain unchanged. So yeah, I get it now. It's not simple as I thought it to be in the first hand. So numbers like 88 or numbers like uh, 11 or numbers like uh, 10, these all are non-symmetric numbers because they are a valid number, but they get okay, I get it. If a number contains 0, so 102 is an invalid, of course. 108 is invalid because it changes to its same thing. Okay, that's kind of interesting. Okay, that's kind of interesting. Let me do one thing. Let me handle this by having a vector of int, right? So let me handle this by having a vector of int 10, all set to false. Let's do this. So what I'll do is basically nothing but numbers could be anything from 0 to 10, right? So I'll just set v of d, right? 0 to 9, right? So v of d would be set to true. That's all I'll have. So when I complete my number, I'll traverse the vector for int I equals 0, I less than 10, and I plus plus. So this is all constant time because 10 is not dependent on input. So if it's 10, I'll see whether I have only these numbers. Let me write. I'll see if I have only these numbers, maybe only 0, 1 and 8, then that's invalid. Only 0, 1, 8 would be invalid. 2 and 5 rotate to each other, maybe. Only, let me see the cases. Only 0, 1, 8 is invalid and contains numbers like 3 and 5, 3 and 4, 3, 4 and 7. Contains 3, 4, 7 is invalid. Only valid when combination of these. So maybe what I need to do is maybe I'll have okay, so let's have 3 flag contains only, and maybe so let's have 3 flags. What do you say? Tool only, and contains, those would be false. So if vi, so if it's true, so if vi and I is equal to 0 or I is equal to, okay, so let's not do that now. Let's do one thing. Let's set only 2, right? Let's set only okay, so let's set contains maybe. So contains becomes my v of 3 or v of 4 or v of 7. So contains become this. If contains, straight away return false. Right. Now let's see what I can do with the only thing. So if it's only contain, so this doesn't contain 3, 4, 7, right? It does not contain 3, 4, 7. It does not contain 3, 4, 7. So 0, 1, 2 3, 4, 5, 6, 7, 8, 9. So it does not contain 3, 4 and 7. So what it may contain? It may contain 0, 1, 2, 5, 6, 8, 9. So if it contains 0, 1, 8, if it only contains 0, 1, 8, 0, 1 and 8. So I'll check for 2, 5, 6 and 9 maybe. Right, so if it contains 2, 5, 6, 9, so I'll tell that it's valid. So if so only becomes basically let's take one only. The bool contains becomes false. So if it's true, then contains, if it's false, then contains becomes val of, or rather v of. If it contains 1, not 1, 0, 1, 8. So if it contains 2, 5, 6 or 9, so it's 2, it's 5, 6 or 9. If it contains these numbers, then return true. If it doesn't contain these numbers, and if it doesn't contain these numbers also, then I don't care what it contains. Either it should contain nothing or it should contain these numbers 0, 1, 8. So in that case I'll return false. Let's run the code. Let's see if this makes sense. Yeah, so for 10 the answer is 4, and let's submit and see. Bingo, and I have completed my session. And this was very random, and I'm honestly speaking, I haven't seen both of these questions earlier, and this is how I walked you through with 2 questions. And let's see. All right, okay, that's great. Thanks.